Okay, this next video I'm gonna go a lot faster, promise. Um, than the first one. It got a little too long. Now we're gonna go over briefly on. Let me show you the plan that we were looking at in the previous video in regards to interior dimensions. The interior dimensions. Keep in mind that you're trying to get the spaces that you couldn't get. Actually, this one should be there. I don't know why I have it there. Actually, it did. Okay, so the walls that you couldn't get to from the exterior, you have to find interior areas where you can put those interior dimensions. For example, this archway, it tells us that it's 480. I'm sorry, 8 feet wide, but we have to tell it. So where do you want this? Well, I want you to go from this wall. Now, how do I know where this wall is? Because this wall goes all the way to the exterior, and I have a dimension for that. So this wall continues all the way up to here, and then from here I wanted to go to 8 and do the archway, and then to 6 to tie it to this one. Now, where do I stop this wall? Remember, this wall went up all the way because we have an exterior dimension for that wall, right? The frame is the brick, the airspace, and the sheathing, and the actual stud. That stud continues up to where? Well, do we have this dimension here? Okay, which is 3 feet. Now, but 3 feet from where? From this wall. How do I know where that wall is? I can get it from here. So it's like a puzzle. It's a map. You have to get all the information that the contractor needs. So the best way to do when you're dimensioning is think as a contractor. Am I giving all the dimensions that the contractor needs to build my house or to put the walls or the rooms wherever I want them? So when doing interior dimensions, keep that in mind. You have to provide all those spaces. For example, here, how big is the restroom? We do have where these walls are and this wall is, but how far is it from here to here? Well, dimension right there. See, you have this wall, you know where it's at. Well, you go to 8, and there's where you frame this wall. See, so it's like a map, but you have to, when you're dimensioning, think as a contractor. Think as a contractor. Now, I saw some of you with this mistake on the assignment I gave you when you dimensioned a plan that I gave you. Actually, it was this one. Some of you were when you saw a dimension, because I didn't give you this, and you were dimensioning. It's a common mistake. You were dimensioning like from here to here. You thought it was like dimension because you saw a tick here and you saw a tick here, so you're saying, okay, maybe it's asking for the distance from here to here. It's a common mistake. The best way of seeing it, if you still have troubles, is that in a dimension, when you have an architectural tick, this tick goes at a 45 degree. So you know that the number goes here. Why? Because the tick is at 45, it's here. Why not here? Because if I were measuring from here to here, these lines are not going at 45. They're going the opposite direction. Okay, so if you haven't actually seen that, that's a little tip. The numbers here, this is not going 45. If you're trying to put the number here, these ticks are not a 45, so that means that that's not the dimension you want, or that's not an actual dimension. Period. Okay, so let me go faster. All right, let me go to this one. We talked about this interior dimension. We just talked about that. Any other appliances do you have? You can also just dimension them. Never assume dimensions. Confirm. Okay, very important information. Very important information. Never assume dimension. Oh, I think it looks like 5. Or it looks like 6. No, you have to find a dimension. And again, if the print is to scale, that's why you can get your architectural scale. That's why I taught you how to read the architectural scale. In case there's a dimension that is missing from the plan, and the plan has a scale, you can go back and get that dimension. Okay, but well, before we go in there, any other information you can also again, dimensions are to give the actual size of a feature, being a wall, being a door, whatever it is. Now, not everything's gonna get dimension because it's gonna get all messy if you do. For example, okay, I went over this. For example, here are some samples there. For example, this one, right? You have a frame. You have a shower in your restroom. You can also just put a liter. which a leader, it's a node that gives information to a feature. In this case, it's a shower, and we can put here 36-inch shower. So that means that this space right there, it has to be 36 inches, which is 36, 36, 36, and 36, which is 3 feet. So just by showing that, the contract knows, okay, he needs a shower here, and that needs to be 3 feet, 3 feet, 3 feet. Now, do you need to tell them where this wall is? Yes. Maybe you can add dimension here from the exterior wall, wherever it's at, tie it to, so they know where this wall is, and then after that, they can tie it to that and do 33, 33, 33. So some of that information, some of the measurements, you can also give them with liters. Okay. This talks about more interior dimensions, but I don't want to go over it again. This too, for example, in some of the doors, you don't have you dimension. Let's see the plan that we have. Let me see this. Now notice here that you have some doors there, okay, but they're not dimensioned. See, where they have the size of the door, but they don't tell you where to put the door. See, they have the doors with the sizes, but where do you put them? If all the doors are to get the space from the wall to where the hinge is, if it's typical, if it's the same distance, you can put a note, and that's what the book is saying. Where's the book? Here. For example, here you can put a note like this. You can put maybe for like say we're doing this plan, the one that I showed you. You can put let's see what the distance is. For example, from the wall to the it's 6.5. Actually, it should be 6. Let's see. Unless all of them are 6.5. 6. Okay, let's say all of them are 6. 6 from there to there. 6 from there to there. 6 from there to there. 6 from here to here. You can put a note on your plans similar to this one. It says here, a door is framed a minimum of 3 inches from a wall using standard construction, whatever. I saw it somewhere else. Looking at different standard framing practice used to center doors between two given ones. Okay, you can put a note. Maybe the plan that, like the one that I showed you, you can put all doors to be framed 6 inches from wall. So the contract knows that whenever I have a door that does have a dimension, I just have to go 6 inches from the wall, and then I can frame my door to the size that it is. So in other words, it goes 6 inches and then 2 feet 8 inches, and they can do that frame or that opening. So in other words, you don't have to put all that information. If you give a note, if it's standard, all of them, you can put all other doors or closet doors to be centered in the closet. So they get the distance from the closet from here to here. They find the center, and then they go, in this case, 2 feet this way, 2 feet that way, and they can frame it. So in other words, you don't have to put all the information there. If you can put a note, that's going to free some space from your drawing, and you're still giving the information that the contractor needs. You're still giving the measurement that the contractor needs. Okay, so just keep that in mind. Let's see where we're at. Okay, so appliance standards, door center between two walls, blah, blah, blah. That's what we talked about right now. Some notes, dimensions are given in notes. That's what we said right now. Brick veneer. Let me show you a picture of a brick veneer in case you're still having issues like what that is. And let me bring this in. This is a brick veneer. Okay, it's a home that it's it's a frame. The actual house is being held, or the structure is being held by the actual frame, which is in this case it's a good picture. This is the metal stud, the wood stud. On the inside it has sheetrock. On the outside it has that sheathing that we discussed in the first video. See, it's showing it right there. It shows that vapor barrier, and then the brick. Now notice there's a space between the brick and the actual edge of the sheathing, which has vapor barrier. That's airspace. Okay. Now this that drops, this is called a brick ledge. And when we talk about foundation plans, we're going to discuss this more in depth. But you have to provide this brick ledge. And notice it's lower than this one. But how do you tie it down? I think we discussed this last time. You have to tie it down with these ties. So they go they're nailed to the wood, the sheathing, and then the airspace is going to be in between, and then this tie goes, the actual tie goes in between the mortar of the brick, and that holds it together. There's another picture here. All right, there's a tie right there. This is space. I'm sorry. I saw one with the actual picture of those ties. Somewhere here. No. The ties right here. See, they're nailed to the sheathing, and then it goes into the mortar, so that's holding. Now here it didn't provide any airspace. Some ties there. Actually, this one, it's a good one too. See, the airspace, and then those are the ties, and that's what holds it. Another tie right there. Okay, so again, why do I show you all this? If you're just looking at plans and seeing how big is the room, because you need to know what is it that you're drawing. Because when you're designing, you need to know what is it that you're drawing. It's spaces that you have to account for, and it's not just lines. Okay, this one over here, they're tied. Okay, you have to tie it. If not, this is gonna be it could fall, right, with time. So you want to tie it down. All right. What else I was gonna show you? Well, I guess I'll come back to it. All right. So brick veneer, some dimension, like I told you before, to the inside of the frame, which is like this, right? But in our case, we dimension to the outside, the way we do it here in the program again. But again, it's your practice. It's not that one is right and the other one's wrong. It's just a matter of practice. If you were to dimension to the inside of the frame, like such, see, they're dimensioned to the inside of the frame, and then the brick, it's on the outside because in reality, the brick is going to be added later. The frame is going to be put up first, which makes a lot of sense. But you don't have to dimension the actual brick. You can put a note. That's what we talked about last time, right? I mean, like a couple of minutes back, that you can put a note to tell the distance, and still tell the contractor to account for the distance. In this case, they put a note here, said 4-inch brick veneer. So that means that from the edge of the frame to the outside is going to be 4 inches. Some have it like this, 5 inches, and then with one air space. That's what this is for. This is 5. Here, counting the air space, and that's it. Oh, this one, they have it on the inside. Let's say you want to have a wall that has a brick veneer on the inside for whatever reason. That's your design. You have to show it, like we discussed on the previous chapter, that everything is a symbol. So you have to put a symbol for it that you have one brick, and then you can put a note to it if you don't want to dimension it. Okay. So you have to tell what is it that you have there, and you have to tell it its size. Now, right now we've been talking about just buildings that are with a wood frame, with veneer on the outside. Now there's something there, the other way of building, which, well, that's different with a building, but another one that we're going to talk about, it's concrete, CMU. Okay, now the actual concrete, it's what's holding the structure, let's say. Okay, and sometimes it's the concrete, and sometimes it's concrete and metal beams, and so on and so forth, but later on you're going to discuss that. So you dimension it a little bit different. Again, we're talking about dimensions. And for example, this here are concrete block construction. And if you still can't picture that, it's this. Okay, so I always bring pictures because it makes a lot of sense. It just makes a big difference. See, right now, this is a building with block or CMU. And now this is what's holding the structure. So it's not anymore a frame that holds the structure, and this goes on the outside. Now the block itself is what's going to hold everything together. See right there. Okay, so now this is what we're talking about now. So a little bit different. So when you do that, you're going to dimension to the outside because that's the actual what's holding the structure, right? And again, here they're going to put some brick on the front because that's the way what the designer wants. Well, they're going to put there a dimension. the main thing that I want to show you is that when you dimension a CMU building, or usually a commercial building, you're gonna dimension. Notice the difference, the way they dimension um, doors and windows. When you use CMU or block, you're gonna dimension from the outside to the edge of either side of the door or the window. Watch. On our commercial building, this is a frame home, we're dimensioning to the inside. Okay, so it's one of the major differences, so make sure you know this. You dimension to the inside of the door, and I'm sorry, middle of the door, middle of the window, and all of them. When you're doing commercial, which I have one here, you're dimensioning to the rough opening, to the outside. See, not to the middle, to the outside of those edges of where the windows are. So it's going to come here, from here to here, 3 feet, in between 3, 4.5, and then from here to here 3 feet. So you're dimensioning to the outside, not to the middle. Again, CMU or commercial, more than anything, is going to be to the outside. Okay? Now why? For this reason again. Oops. Come in. For this reason, that whoever's building, right, they put in the rows of brick like that. So once they come to an area where they have to put, they're gonna have door or window, they have to frame. So they need to know, since they're putting rows of brick, right, they go row by row like that. You start with one row, another one, another one, another one. They need to know when this one is let me see if I find another one. This one. See, they put one row, another one, another one, another one, another one, another one, another. Now here they need to know, okay, I have a window here. Tell me where it's at so I can stop, give you that distance you want, and I'll continue. So I can give you, and then they need the height, so know up to where they're gonna put it and put a header there. So that's one of the reasons we want to dimension to the rough openings. See right here, a bunch of rows, and then they have to frame or provide that space for the window or door. So when you're dimensioning in CMU or CMU building, you're gonna dimension doors and windows to the outside. And then same as the other one, remember, we did doors and windows. In this case, we only have this door. Interior walls and major breaks. This is a square, so there's no major breaks. So again, here, doors and windows. I have a window here, I dimension there. I have a window here, I dimension right there. The other one is interior walls. I have an interior wall there. Actually, we missed that one. We should have one dimension there, one dimension there, one dimension there, and then the overall. And the interior dimensions go all the way. All right. We'll discuss that in a bit. All right. So let's go back over here. So there's one of the major differences when you're mentioning CMU construction. Read over this. I don't want the video to get too long, but read over this. Very important information. Very, very important information. If we have time, we're going to cover it in class. The benefits of doing masonry construction. But again, the book is very detailed, so please read this in your book. This I want to show you too. Veneer, wood framing or fur out optional for interior walls. Furring, this is very important too, and I want to show you what it is. You can do furring if it's, again, we're talking about solid concrete or CMU construction. But let's say you want to do, it's a CMU construction, which is brick, but you want to put some sort of you want to put more insulation on the inside, even though a brick home or a block or concrete, solid concrete is very good in insulation. But let's say you want to add more, or you want to put sheetrock on the inside. Of course, you won't be able to nail the sheetrock to the actual block, or if it's poured concrete, even worse. So you do furring. Now what furring is, let me show you a picture. It's this. See, you have your block. That's a wall. That's what's supporting the actual structure. And this is furring. You come inside and you lay it out and you do like if it was you do these cavities with a 2x4 or 2x6, whatever you want, depends on how big you want the cavity. And then here, I mean, you could put insulation and then nail the sheetrock if you want to. Okay, so this is furring. Okay, this is furring. So if you see it in a note, this is what they're talking about. All right. So where we use this, I've seen it like in we're actually up north, where they have basements. They do this. They seal it first, make sure it's sealed from the inside and the outside for humidity, and then they provide, even though it's already very good insulation, but let's say they might want to put more insulation there, and then even and for aesthetic purposes, they could put sheetrock and then put texture and then paint it. It looks nice. So this is furring, and the book talks about it. So I just wanted to show it to you what it is. Now, in furring, when you fur a room or a building, the CMU is holding the structure. This is just for the purposes of showing or insulating or putting a material on the inside. In the contrary, as of a frame home or frame structure, which is this not there? Okay, I'll close it. Which is the opposite. Which is that in this case, the structure is being held by wood, and the brick is just the for viewing purposes. So it kind of works the opposite. I'll close this. Okay. Now, so there's some other information that you need to know, and I'll finish with that. When you're looking at a plan, it gives you not only dimensions, but there's other information you have to look for, or that it's very important for you to either tell the contractor, or if you're reading it, you need to know what it means. For example, showers, and here it's hard to see. If you see the one in the book, it's a lot clearer than this one. Some other information, for example, something I want to show you. Again, you're designing the house, so one thing that some students don't think about, it's that when you're designing the house, you're thinking about just walls, which you should, right? You're thinking about the layout, which you should. Where's the light coming in? Where you're going to put your doors? Where's the best area to put? How big should I do the spaces so it provide an actual space that someone's going to need? But when we look up, usually we tend not to pay attention to the ceiling. And you need to tell the contractor, if you're going to do something with the ceiling, you have to put it there. For example, here, you see these hidden lines? There, there, and there. And then you see some notes, and again, they're hard to see. They have a hidden line there, and then they have a line, they have an arrow pointing to each other towards that line, and then to this side, they have 11 ceiling height, 11 feet, and this side, 9 feet ceiling height. So that means that if you're walking here, on this sort of hallway, it's 9 feet. Once you get to this point, the ceiling is gonna go up 2 more feet. So this ceiling is higher than this one. So you're walking on a 11-foot ceiling. You're still on an 11-foot ceiling. You're still on an 11-foot ceiling. But when you get to this point, when you go from the nook to the kitchen, it's gonna drop to 9 feet again. Okay, and it's gonna be in this shape like that. Okay, so that's something you have to think about too. For example, now here the dining. You're in the kitchen and the family room, the ceiling height is 9. Even when you go through this door, right? It's dining. But the dining, it's open to the living room. It's an open area, there's no wall. But the ceiling does change. Comes here, this is 9-foot ceiling. And then once you get to this point, the ceiling is going to go up 2 feet higher to 11 feet. So again, you're a designer. You're thinking about, I'm walking into this room, just by pulling up the ceiling, it's gonna make my room look a lot bigger. So that's what they want. See, they want the entry to look bigger, bigger than what it is. The nook to make it look bigger. The living room, you want to make it look bigger. Even the spaces might not change, but just by having the ceiling a little bit higher, it makes everything look bigger. And the other areas, it look kind of more cozy. For example, 9 feet down, so now it's a little bit different. It's different, or it's more cozy. And not only for that, but if you notice, there's no wall from here to here. It's open. There's no wall from nook to kitchen. It's open, right? You walk and you walk straight. There's no wall. But by providing this difference in the ceiling, visually you know where you're in the nook and where you're in the kitchen. By providing this difference in ceiling, again, this is open. You can walk across. But by providing this difference in the ceiling, now you know when you're in the dining room and when you're in the living room. See, there's no actual wall. but in the ceiling, it will tell you when you're in one room and in the other. So again, you as a designer have to think about these things. Okay. Uh, Briefly, let me just show you one last thing because it's specs. This I want to cover in class. This is very important. That specifications, they're like the Bible of the construction project. It tells you a lot information in detail. So I'm going to go over this in class. Okay. I don't want to go into the metric. I just want to show you this drawing revisions. This is very important. Let's say you make a drawing, and or the firm you're working for, they make a drawing, they send it out, and then the owner comes back and makes a change. They want to change, or the contractor wants some clarification, and you notice you made a mistake, or there's a change you have to make. You do a drawing revision. You have to, in the drawing, do a cloud and make a note of what is it that is changing, and then you have to record that. Okay, the set of drawings that you have in front of you when you're drawing, those drawings, they're a contract. See, they're a construction document. So what's there is what's going to get built. So if you make a mistake, you have to come back and adjust it or make a revision and note it that it's a revision, and they have to update and tell the contractor or everybody else actually involved in the construction of that building that you have made an addendum. Okay, here's this contract addendum. Whatever change you have made, you have to do an actual contract addendum, and everybody involved have to know of the change that it was made. But in the actual drawings, you show it with a revision. You show it with a revision cloud, like that. Okay, for example, in this one, they made a change, and here's hard to see. Let me read it in the book. It says mechanical units approximately 12 inches below parapet line typical. So they made a difference. They made a change on these units that they have on the ceiling. On the roof, right? They made a change on that, and this is a change they did. And now notice how they did a cloud, and they did it with a note, and then they point to the actual units, mechanical units, and also put a cloud there with that symbol 1, or triangle 1, and they bubble it. So when you see something like this in a drawing, that means there was a revision made. So if you go through a drawing and you see a cloud, it's not saying that that it's an actual cloud. It's a cloud. It's a revision cloud. So whenever you see something like this, it's telling you something was made, and it tells you what the change was. And then this gets sent to everybody. Whoever gets the sheet and sees that cloud, just by seeing that cloud, automatically something changed. Let me look at it. Okay, so these are revision clouds. So if you see them, that's what they mean. If you need to make a revision on your plans, when the construction has already started, you come make the change on your plans, put a revision cloud on it, put the note that what it changed, and everybody involved has to know. And this you have to document. That you have to document because again, your drawings are. It's something were to go wrong. They're gonna come back to the drawings, the lawyers, and gonna say, okay, whose mistake was it? So what do? You record it on your title block. Remember, you have an area for revisions. You code it with a 1 and that triangle, which is a symbol, right? And you don't put here what it was. You just put the symbol, and then you go to the plan, look for that symbol, and it tells you what is it that it was changed. And you put revision 1, and you put the date. In case a contractor comes back, the guy that installs the units and puts them wrong, and says, nope, you never told me. Yes, I did. Here is a addendum I sent you. Here is a revision cloud, and I did it this date. You're the one at fault. So it's for lawsuit purposes. But whenever you see something like this, it's a revision cloud. Something was made, and they have to tell you what it was, where, and then it also has to get recorded. Okay. There's a lot more to discuss. Hopefully in class we hit some time to touch on those things. But please watch these videos. Well, again, if you're watching it or you hear me say that, it's because you watched it. But please read your book. Read the chapter. It's not a long chapter. And this video, you can watch them over and over again if you need to. And again, I apologize for going too long, but it's a lot of information that I want to show you. In class, I'm going to go some of this information, but not as in depth. So, again, any questions you might have for any of the chapters or anything we have covered up to now or all these 4 chapters, please let me know. All right.